determine whether the series is convergent or divergent. So we got a series n factorial over n raised to n. So there is a factorial sign. That means that gives us the hint to make use of ratio test, where we find the limit of absolute value of an plus 1 over an, and it comes out to be something. If that limit is less than 1, the series converges. If the limit is bigger than 1, series diverges. If this limit comes out to be 1, then this ratio test fails. We need to use different tests to conclude about this series. Okay, so we have here, this is an. Okay, so let me write that. An means this one, n factorial over n raised to n. Now using the ratio test, limit n going to infinity, absolute value is not necessary for this question because everything is positive, because n is going from 1 through infinity. So I don't have to write this absolute sign. An plus 1, so the next term, this is an, so an plus 1 means replace n throughout by n plus 1. So an plus 1 will be n plus 1 factorial over n plus 1 raised to n plus 1. So that is an plus 1, that's the top part, divided by an, which is this. Okay, let's compute this. Now I want to change this division into multiplication, so we need to flip this. N, okay, at the same time, n plus 1 factorial, as we know, we are getting n factorial here, so n plus 1 factorial is n plus 1 times 1 less, so n plus 1 means n times n minus 1 all the way to 1, or we can write just n plus 1 times n factorial. Okay, and n plus 1 raised to n plus 1 is same as n plus 1 raised to n times n plus 1 raised to 1 raised to 1. Okay, so I'm going to simplify like that. So n plus 1 factorial on the top is n plus 1 times n factorial over n plus 1 raised to n plus 1. I'm just simplifying here, n plus 1 raised to n times n plus 1, as we discussed earlier here. This division into multiplication, so this fraction flips, n raised to n over n factorial. Now you can see n factorial on the top and bottom cancel. Okay, and here we got n raised to n, here we got n plus 1 raised to n, and here is n plus 1, here is n plus 1 as well. So we can cancel these two as well. Now we have, then this is limit n goes to infinity of n raised to n over n plus 1 raised to n. Okay, now we need to compute this limit. Okay, so when we take n to infinity, then this goes to infinity over infinity. So we can use L'Hopital's rule of calculus 1. But let me simplify this first. Okay, this is same as limit n going to infinity. I have power n, so I can write everything raised to n. So n on the top over n plus 1. Okay, now what can be done? Now let me recall something from calculus 1 when we have 1 plus 1 over n raised to n, and if we let n go infinity, this is defined as an exponential function e raised to 1. In fact, if we had here x, then this would have been x. Okay, if we have x here, this should be x. This is how exponential function is defined. And if we have a number, I'd say 2 e squared, so 1, this will be e raised to 1, where e is an irrational number about 2.72. So I think we can convert this in something like this. Let's see. So this one is, I have raised to n. I want to write this fraction as when we have like a over b, this is same as 1 over b over a, because this fraction flips and comes back to this. So I can write 1 over n plus 1 over n. Okay, this n. If I change this division into multiplication, then we get this back. So I'm kind of making something similar to this. Something raised to n, 1 over, on the bottom, this is n plus 1 over n. We can separate into two fractions, n over n plus 1 over n. N over n is 1 plus 1 over n. So here n over n plus 1 over n is 1 plus 1 over n. Oh, that's exactly like here. But we have 1 on the top. So 1 raised to n is always 1. So let me write in this way. On the top, 1 raised to n, just 1. On the bottom, 1 plus 1 over n raised to n, because this is for the top as well as for the bottom. And the bottom is exactly like this. So this one is e. So when we take this limit, this is 1 over e raised to 1, this one. And this is about 2.7. 1 divided by 2.7 is less than 1. So this is less than 1. That means the given series converges because this limit is less than 1. So implies the given series n over, oh no, n factorial over n raised to n 1 through infinity converges. Final.